We have already studied about the hexagonal cell structure. Now, we will discuss about the cell geometry, how these cells are formed, and that is called the cell geometry. So, again we are coming to the 7 cell cluster. How this 7 cell cluster has been formed? This is now the question, and here in the cell geometry we will discuss how these cells are formed in different clusters. For example, this is the 7 cell cluster. It may be 3, it may be 9, 13, 16, 25, but in which manner these are formed. So, this is the subject of study here about the cell design. See here, there are number of cells. Let us consider the center of all these cells as a, say, this is u axis and this is as a v axis, and our aim is to find out the distance between C1 and C2. You have gone through the coordinate geometry. We have to calculate the distance between the C1 and C2. How will you calculate? If we can calculate the distance between C1 and C2, we may find out the larger structure for these cell constructions. Let us see how to calculate the distance between C1 and C2. The distance between 2 points, which are the center of cells, and these points are C1 and C2. The distance may be, according to coordinate geometry, the distance between C1 and C2 we say d, and we take the coordinate v1 and u1 in C1 and v2 and u2 in C2. So, distance between C1 and C2 will be u2 minus u1 square cos 30 square plus b2 minus b1 plus b2 minus b1 into sin 30 whole square, because this is the 30-degree angle and we have shifted the coordinate from here to this place. So, in a triangle you can find out the side of a triangle in terms of sin and cos. If we shift the coordinate u1 and u2 to 0 0, then the sin and cos goes and we can shift the coordinate from here to this place. So, distance between the C1 and C2, if we take u1 and v1 as a 0 0 coordinates, vt and u2 as a I and j, they are two integers. Then distance between C1 and C2 becomes I square plus j square plus I j. This is the formula we have got. The actual center to center distance between two adjacent hexagonal cell is 2 r cos 30 or under root 3 r, where r is the center to vertex distance. What it means? In a triangular cell, this is the r, this is the equilateral triangle. So, relation between d and n. What is d? the distance between 2 points C1 and C2, and n is the noise. So, therefore, D is the function of S1 and N1 received signal to noise interference ratio at the desired mobile receiver, and N is the number of co-channel interference rings cells in the first tier. So, N is the co-channel interfering cells in the first tier. If you get the 7 cell cluster, these are 6 in number, but if the cluster size is different, the N will be also different. So, what is the relation between D and N? We put the formula here, and the relation between D and N comes out to be D by R is under root 3 n. In some of the book it is written as a Q, but some of the author write it as a K. The Q and the K, they are the same thing, do not confuse. So, this is called the reuse factor. Let us see, find out the reuse factor. These are 2 cell structures, 7 cell structures, and from center of this cell structure to this one is called the D distance, and it is known as a D by R is equal to Q also, and D is the this sector. See it again here. Where is R? This is the distance R, and this is the distance D. Our aim is to find out the D by R, that is under root 3 n. This is also called as a reuse factor. So, this way we can calculate the reuse factor to decide the number of cells in a structure. If we put the different value of I and j, say take the value of I either 1 or j is equal to 0, then we get q or k is equal to 1.7. In the random way, put I is equal to 3, j is equal to 0, so we will get 5.2. So, in this way we can find out different values of reuse factor and the number of cells in a cluster. So, we can calculate what is the value of I, what is the value of j, and accordingly what is the value of n, and based of that what is the value of reuse factor. The reuse factor is important deciding the distance for reuse purpose of the 2 cells, either in 7 cell cluster or in 3 cell clusters. Now, we will discuss about the cell geometry. What is the purpose of discussing the cell geometry? It depends upon what is the type of city where we are going to give the cell structure. The city like Chandigarh, which is square in nature, therefore, the cells you can put the cells same in I direction and cell in j direction. But the city like Bombay or city like Delhi, Delhi is the circular type, but Bombay is totally different. It is of this type. Then we have to decide the value of I and j to cover the whole city, and this is the purpose of cell geometry here. So, how many cells will be in a cluster written here? N is equal to I square into j square into I j. I is the number of cells to be transferred along the direction I. J represents the number of cells in direction 60 degree. So, which direction how many cells are required will be decided by value of I and j. Let us see how these cells are formed, the cell formation. Put different value of I and j in this equation. N is equal to I square plus j square plus I j. So, we will see here how the animation comes. So, see here in this animation how this value of n changes when the value of I and j changes. See here, the spot has started, it has gone to 1, put the value of I and j is equal to 1. So, it comes to 3. Now, if the same spot the j goes to 2, put the value of j as 2 and I is equal to 1, it becomes 7. So, this is the 7 cell cluster. In the similar way, depending upon the situation of the city, we can decide what should be the value of I and what should be the value of j, because all the cities are not symmetrical, not circular, not square, shape may be totally different. If you are providing the circular or square pattern for the clusters and there is no population, your efforts goes as waste. So, we have to design the cells according to need of the city. So, what are the other choices? You have seen the figure. If you repeat the value of I and j in different directions, you will get the different values of n, and these may be 1, 3, 4, 7, 9, 12, 13, 16, so many. If you change the permutation and combination of I and j, get large number of cell clusters, and these cell clusters are according to your requirements. The very small cities may not need the cell cluster of 21 or 7 or 8 or 9, maybe 3 may be enough. If the place is very small, even cell cluster of 3 is much more enough. If the city is very big like Calcutta, Delhi, hundreds of cluster will be required to cover the whole area. So, the cell design and cell geometry will provide the solution for this one. What are the most populous cell cluster? The most populous cell cluster are 7 and 3. There may be many possible clusters which has different values of n, but depending upon the requirement we have to choose the popular clusters. See what are the popular clusters? The animation is sometime working or not. See what are the popular clusters? 7 and 3. So, accordingly the value will be I and j will be adjusted here to get the cluster of 3 or cluster of 7. These are the popular cluster. If I and j both are 1, then it is 3. If I is equal to 1, j is equal to 2, it becomes 7. So, we find out the design of the popular clusters. Let us see if we can find out some other cluster. Cluster may be 3, 7, 9, 13, maybe any clusters. So, different type of clusters. Here it is 1 cell cluster, it is 3 cell cluster, 4 cell cluster, 7, 9, 12, 13, 16 and so on. Depending upon the city situation and physical structure, you have to decide the cell cluster. So, this was about the cell geometry and frequency reuse. Now, I will give you one example to calculate the reuse distance. See this figure. It is clear from the figure. This is the 7 cell structure. All these are 7 cell structures, means you know the value of n easily. And what is given here? Calculate the reuse distance if the radius of each cell in the above given figure is 2 kilometers, means r is equal to 2 kilometer. What is value of n? 7. Then you can calculate the reuse distance. What is the reuse distance? D under root 3n into r. This was the reuse distance. So, you can calculate the reuse distance. So, in this lecture we have discussed about the frequency reuse and the cell geometry. In the next lecture, we will discuss about the other parameters of the cell design. Thank you.